Hey guys, Alex here with Serious Goose Games. Welcome back to our Unity Tactics RPG tutorial. Last time we added movement costs and restricted our units' movements. Today we're going to make it so our units snap to the grid and fill the tile they're standing on so it won't be factored into movement. So the first thing we're going to do is hop into our grid manager script, and we want to add an overloaded method of getTile. So right now, getTile accepts a vector2 int position. And what we want to do is add another version of this method. So we're going to do public tile called getTile, and we're going to pass in a vector3 called position. So when you overload a method, what you're doing is you're changing the arguments you pass into it so that you can call the same method and give it different values to get essentially the same result. The benefit is we can use the same method to do the same thing with any inputs we need to give it. So inside here, we're going to create a float called offset x, and this is going to be equal to width divided by 2f. And we're going to create another float called offset y, and this is equal to height divided by 2f. Now, if you didn't offset your map, if you just passed in x and y when you instantiated your tiles, you don't need to offset. But because of how I instantiated the tiles, how everything is offset by half of the map's dimensions, I need this offset or it's not going to be accurate. So now we're going to create two ints. First one is going to be x, and this is equal to mathf dot round to int, and we're going to pass in our position.x plus our offset x. And you could probably guess, but we're doing another one for y, and this is equal to mathf dot round to int position.z plus offset.y. And then we're going to return map x comma y. So this is going to take the world position of whatever our object is. So if we have our units and it's sitting at world position 5.3 on the x-axis and 0.5 on the y-axis and 2.6 on the z-axis, it's going to grab those. So what I say, 5.3, 5.6, whatever, 5 for position.x plus our offset, which is 5. So that's going to be 10 for the actual tile it's on. And it's going to grab that tile and return it. And then what we can do is we can snap the unit to that position. Now what we're going to do is scroll all the way to the top. And instead of start, we're going to change this to awake. So in Unity, you have a bunch of different kind of built-in methods. Awake happens first, then start happens, and then update happens every frame. Then you have late update, which is slightly delayed, and then fixed update happens at a fixed time frame. That's where you want physics stuff. So awake just happens first, before everything else. And that's going to make sure that our grid is there first before we call any other start methods on any other scripts. Now, if we had a bunch of scripts and they all had the awake method in them, we would need to mess around with the script execution order in the Unity project settings. But for now, we've only got one. So let's hop on over to our tile script, and we're going to add a bool. Public bool is occupied. We're going to set that to be false by default. Now we're going to hop on over to the player script, and we want to add the system.collections namespace. So using system.collections.generic, and that's so that we can use lists, because we are going to now add a public list of player units. So this will just be, we'll put in the units that we start with at the beginning, and then say we have a mission where you can recruit a new unit. Partway through the mission, we can add it to player units and remove it from the player units of another player if it was, say, an enemy or something. So now we're going to add a method in here called snap units. Private void snap units, and we don't need to pass anything in. What we're going to do is for each unit in player units, we're going to grab a tile reference, and this is going to be called unit tile. And we're going to set this to be equal to grid manager dot get tile, and we're going to pass in our unit dot transform dot position. Now we're going to grab our unit dot grid position, set that to be equal to unit tile dot grid position, and we will snap our unit dot transform dot position to be equal to our unit tile dot transform dot position, and then we're going to set unit tile dot is occupied to be true. Now we're going to call that up and start. So underneath where we grab our grid manager, we're going to call snap units. Now we're going to go back to our grid manager. We're going to go down to or get highlight range. And where we check to see if a tile should be considered, we're going to add a condition here. We just want to check to see if the neighbor's occupied. We want to make sure they aren't. So exclamation point, neighbor dot is occupied. So now on top of checking if it's within range, if we already have it in our dictionary, we're also checking to see if it's occupied. If it's occupied, we don't want to do it. So we only want to run this if it's an open tile. So the problem we have at the moment is we assign occupancy at the beginning when we spawn in our units, but our units have the ability to move. That's kind of important. So we need to make sure that when we move the unit, we change the occupancy of the tile it was on. So in our tile script in on pointer down, where we move the player, we are going to get component in parent, grid manager, and we're going to call get tile, and we're going to pass in player dot selected unit dot grid position. We're going to set the occupancy of that tile, so is occupied, to be equal to false. Now, we're probably going to end up storing this grid manager reference later, so this is subject to change. But for now, get component in parent works fine for us. Later on, we can create a reference and store it in start or something. The last thing we're going to do is set is occupied to be true on this tile, because this is the one we're moving to. So go ahead and save all your code and head back to Unity. So the only thing we have to do here is select our player in the hierarchy, look at our player units list, see how it's empty. We want to drag each unit into that area. So grab unit from the hierarchy, drag it on top of player units. So that's highlighting. You see a little box with a plus sign and drop, and it adds it to our list. And we can do that with each one. Now, each of our units already has kind of a whole number position here, so nothing crazy will happen. But if I hit play, you see they are still snapped to our grid. The other thing is occupancy is now a factor. So if I select this unit, we can see we can't actually move onto the tile that he's on, and our movement range isn't enough to allow us to move behind him. Whereas if we look at this guy, his movement range would allow him to move there, but because he has to go around, he can't reach. So the next video is going to be a big one. We're going to implement A-star pathfinding so that our units actually follow a path that we want them to take. They're going to take the shortest path to get to wherever we select instead of just gliding to it. With movement ranges this small, it's not really a big deal. But if we were to increase our movement range to like 7 or 8, then it might be a little better looking if they actually followed a path to get to the tiles they needed to get to. That's all for today though. So if you like this video, hit like so other devs can find this series, and subscribe so you don't miss the next one. Let me know in the comments if you would make units impassable. Our current system makes it so you wouldn't be able to move your own units through each other. I kind of like it. It makes it so that you have to be more aware of positioning, but I could see how some people would dislike that and want a different system. Another thing I want to mention before ending off is in the description, you will find a link to the GitHub where this code is posted. So each episode has code that you can go and look at and compare. If you are running into issues, you can debug using it. It also has a list of things that have changed between episodes. And I'm also going to be including useful resources in there as well. So take a look. As always, thanks for watching. I'm Alex with Serious Goose Games, and I'll see you on the next one.